I want to go through 3 real-life examples using actual data to show you how you can take output, regression output, and make sense of it in terms of plain English. What does it all mean? So the first question we're going to look at is how well does persistence in high school predict overall college GPA? So persistence is this idea that you're going to keep trying, even when you run into problems. You're not going to give up easily. So that ability to persist, how well does that predict later in life when you get into college GPA? And notice this word predict. This is just saying there's some kind of correlation. This is a great question for a regression or for a correlation. Regression in particular, because we want to actually make a prediction. We want to be able to say, oh, okay, early in high school, this student's persistence level was this. Based on that information, we're going to predict that their college GPA is going to be this. So this is the perfect scenario for a regression. So I ran this on a data set, nationally representative data set, 16,000 students, but they represented the entire 3 million sophomores at that time in high school. So it's some pretty good data here. And each of these students here, each of these dots is a student. You can't see all 16,000. On the bottom here, this x-axis is persistence. So they were given a series of questions that helped to rate their persistence, and those were all then changed to z-scores, like we saw back with normal distribution. They were changed to z-scores. So this is the z-score of their persistence. In other words, how did their persistence level compare to all their peers? So a 0 would be right in the average. 1 would be a standard deviation above their peers in terms of persistence, and so on. So negative doesn't mean they don't have any persistence. It's just they have less persistence than their average classmate. And then on the y-axis, we just have GPA. So on the scale of 0 to, back then, I think they cut it off at 4.0. This was before all the higher GPA options. So where do we go first? This is a regression output. I definitely like to visualize it first, even though with this many points, it's not so helpful to visualize. But the first thing we want to go to is right here. We want to answer the question immediately, do we have good evidence that persistence in some way can predict college GPA? High school persistence, can it predict college GPA? This is called statistical significance. It's a yes-no question. And we're going to make our answer based on how low this significance f is. This is also called a p-value. You may have heard of p-value. This is the p-value for the entire model. So it's the kind of the key into the model. It's below 0.05 is typically what we're looking at for statistical significance. So lower is a greater chance of that there is a connection between these two. And this e negative 32 means times 10 to the negative 32. In other words, it's this number with the decimal moved 32 places to the left. So it's 0.00, about 31 zeros, then a 3. This is a extremely low number. It's well below 0.05. So because of that power of 10 there, this number is well below 0.05. So we can say pretty convincingly that there is a connection between high school persistence and college GPA. Not that this causes college GPA to change, but that there's predictive power. If we know someone's high school persistence early in their sophomore year, then we can predict, we have some predictive knowledge about their college GPA. Now, how much knowledge? That's a really good second question. So this tells us whether or not there is some kind of connection. Here's where we go to see what the correlation is. What's the strength between these two variables? How closely are they related? If you think back to that correlations guessing game, how close would the dots fit to a line? However, there's one little catch. This gives the strength, so that number is right, but in order to get the sign of our correlation coefficient, sorry, we need to go, I didn't put it there. The sign comes down on the slope of our regression line. So our regression line is going to be down here. The slope is going to be the thing that's not the intercept, the second thing. So this was a positive slope, and that tells us that our R value would be positive also. So to get the R value, you look here for the number where it says multiple R, and then to get the sign, you have to go down to the sign of the slope down here. So if this had been a negative, our R value would be negative 0.13, but it was positive here. Okay, then we can square that R value, multiply it by itself, just like we saw with correlation, and we get our R squared value. This is where we get practical significance. So this here is how sure are we that there even is a connection? This is telling us how strong is that predictive connection. And as we said before, R squared could be interpreted as a percent, so we'd move it over 2, and we'd get 1.8%. So 1.8% of the variation in college GPA, different people have different GPAs in college, so what's related to or predicting that differences in college GPA, 1.8% of it can be somehow tied back to persistence early in high school. Now, this doesn't say that it's causing it, but the predictive power is 1.8%, which means 98.2% of the variation in college GPA is connected to other things unrelated to persistence. So this is telling us this is a pretty weak effect here. Only 1.8% of the variation in college GPA is somehow explained by persistence. And then finally, we jump down here. This is where we're going to get that regression equation that we looked at earlier in a video. So our intercept is 2.74, and our effort persistence, our slope, is 0.119 or 0.12. In other words, the equation is predicted college GPA equals 2.74 plus 0.12 times whatever the persistence score of a student is. So if they were exactly average on persistence, which would be a z-score of 0, then their predicted GPA would be 2.74. But let's say that they were up here and they had a little bit more persistence, so they were a score of 1 on persistence. Then it would be 2.74 plus 0.12 times 1. That would put them up as a predicted college GPA of 2.86, so a little bit higher. And similarly, if they had a negative something, we'd have negative times this 0.12, and that would bring their predicted college GPA down. Here's another question. Does frequently attending religious services, so when you're a parent, with your child, improve their job satisfaction later in life? So initially, you might think they're disconnected, but then think a little bit more. And this was a big question that my wife and I discussed about going to church and putting values into our children and how that might impact their life later on. So it was a very real question for us. Still, that's pretty far apart. We're talking early in high school, and then maybe job satisfaction in the mid-20s, in their mid-20s. That's when this particular data that I have is. So pause this for a minute and ask yourself whether you think they're connected. And then let's take a look. But there is a key word here, improve. This is a causal word. Unlike predict or associated with that are just correlational words, this is actually causing. So we're saying that attending could actually cause them, not just predict, but cause them to have higher job satisfaction. And this is something we can't quite do with the regression, or at least not a simple regression like we're doing here. We can get the correlation, so we can predict their job satisfaction potentially from knowing about their religious service stuff, but to actually improve it is a bigger step. So I ran the data. This is what it looks like. At first, you might think, well, the scatter plot there is definitely wrong. But it turns out that this variable only had a few values. So this is correct. On the x-axis, we have how often, how frequently the parent attended religious services with the child. So this would be never. This would be sometimes, kind of often, very frequently. And then on the y-axis, we have these same students 10 years later. They collected data on them 10 years later. And where was their job satisfaction? Again, this is somewhat of a z-score, so a 0, it looks like their average is actually a little lower, but the higher it is, the more satisfied with their job they are. So you can't really see much at all from this scatter plot. But we do have the output here, so let's dig in. Where do we go first? First, we go to that significance f. Remember, that should be below 0.05, and it is. So again, we answer the question, yes, it does look like there's some connection between religion and job satisfaction, or attending religious services and later life job satisfaction. Then we go to, oh, sorry, my PowerPoint slide had slid there. So the correlation, again, we go here, and this gives us the strength. So our R value is 0.03, but to know if it's positive 0.03 or negative 0.03, we need to jump down here to the slope of our regression line. And that does turn out to be positive. The intercept's negative, but we only care about the slope here, and that's positive. So our R value is indeed positive 0.03. In terms of practical significance, our R squared value, if we roll that over to, that's 0.1%. 0.1% of the variation in job satisfaction is somehow connected to how frequently the child attended religious services earlier in life with their parents. So very, very weak. It is positive, so it is true that the more they attended religious services with their parent, the higher their job satisfaction tended to be, but that's a pretty weak relationship here according to this data. And then we go down to the prediction equation or the regression equation, the trend line. So the equation would be predicted job satisfaction equals negative 0.08 or 0.09 plus 0.029 or 0.030 times whatever their score was on that religious variable, that X variable, how often they attended service. So if they didn't attend any, that would have been a 0, and their predicted job satisfaction would be a negative 0.08, that's a legitimate value here because there are negatives. If they attended frequently, say 3 was their score here, we would take 3 times this, get about 0.09, and then their predicted job satisfaction would be just above 0, so slightly positive. So not really getting much of a difference there at all, but there is a slight predicted difference. What about if we took a attended religious services of 10 and plugged it into the model? Well, we could do that. It's an equation. We could get a predicted job satisfaction score, but we have to be careful here because not only does that not even make sense, 3 was already a 10 frequently, but you shouldn't predict too far outside of whatever range of X values you have. So if these are your potential X values, you shouldn't make a prediction for an X value that's way out above or way below these values. That's called extrapolation. And the danger there is we really don't have data out that far. So our prediction certainty or accuracy is going to be much lower in that case.